Now in this video, I've got a 10 volt DC source in parallel with a 100 ohm resistor and a 150 ohm resistor. Now this is obviously a parallel circuit. So I've got 10 volts here and I've got 10 volts here. And so my current through my 100 ohm resistor, right, I equals I'm going to call this my R1 resistor and this one my R2. So the current through my R1 resistor equals 10 volts divided by 100 ohms. That equals 0.1 amps. And my current flowing through my 150 ohm resistor, IR2, that equals 10 volts divided by 150 ohms. And that gives you that equals 0.066 amps. Okay, so now that I know my voltage and I know my current, I can now calculate my power. So now the power that is in my 100 ohm resistor equals 10 volts times 0.1 amps that equals 1 watt. So my power in my 100 ohm resistor equals 1 watt. Now I'm going to find my power in my 150 ohm resistor. That equals 10 volts times 0.066 amps. That equals 0.66 watts. So now my total power equals 1 watt plus 0.66 watts. That equals 1.66 watts. Now my total current, IT, equals 0.1 amps plus 0.066 amps that equals 0.166 amps. Now, I can also find my total power by multiplying my total voltage by my total current and I will also get 1.66 watts. Now, it's important that you know the wattage rating for your resistors, because if you don't and the watt is too high for the resistor, then you may end up burning up your resistors. That is why it's important for you to know the watts so that you select the resistor that can handle the wattage. And this brings me to the end of the video. Subscribe, like, share. Subscribe, like, share. Thanks for your attention.